Because we have a bit more time, I'll do a quick sweep through of how to simulate coronagraphic observations with PanCAKE, if you're interested. So PanCAKE is this simulation tool that does a lot of this stuff I was just showing you just on simulated images. So you can make contrast curve predictions of the performance of JWST, as well as subtracted images of what the images you might expect from JWST are. And the way that works is very, very quick and very easy. You can go grab PanCAKE and just import the PanCAKE package as follows. You import it, you define some target scene, for example, HIP65426, where we've just added here, we'll add a source, we'll call it HIP65426. We'll tell it, go look on Simbad for that name and download all the information you need. We'll add another source for the planet. We'll tell it where it is in R theta space. We'll tell it we're giving it a file. This is the file name it needs to look for. And these are the units of the spectrum we're giving it for that particular source. So we've created that scene now for our target. And you can see kind of how that looks by just quickly plotting it up in PanCAKE. You can see this is the kind of positions we've put in. This is the kind of the spectra we've injected or have been downloaded and understood from Simbad, just to check everything works okay. Then we can add another scene for our reference observations. We'll go off and observe a different star. Here we'll call it reference, and we'll add another source with Simbad, just HIP68245, which we know is our reference star. And then after that, we just want to start defining a sequence of observations that we want to perform. You can imagine this like, go here, do that, then go here, do that. Just a list of instructions, really. So that's what we're doing here. We'll tell it, add an observation of the target, add it in this filter here. We'll give it these exposure parameters. This filter as well with these exposure parameters. We want to use this mask. We want to do some sort of roll. And then we'll do the same for the reference target, except we'll also add like a dither to get those different realizations of the PSF, the residual PSF. And then after we've set that all up, and you can really set this up for an arbitrary amount of things, you could add a whole bunch of scenes, a whole bunch of sources, a whole range of different observations. You just hit go, and then you can give it some different things to tweak. Do you want to generate these model PSFs on the fly, or do you want to use a pre-computed library? Do you want to evolve the wavefront throughout these observations? And then how precisely do you want to sample the wavelength of your spectrum in each bandpass? And that can affect just, how long these things take to run. And then once you've hit go, you can start to use those results, just load them into this contrast curve function of the analysis. You tell it, this is our target. This is the references we're using. I want to do an ADI subtraction for both of these filters. And it can start spitting out these images to you, like I show here. So you can see, we're seeing the planet here in ADI, RDI, and ADI plus RDI for the NearCam filter, MIRI. ADI didn't do such good job, which is actually very similar to what we're seeing on Sky for this particular filter. But RDI and definitely was able to recover the planet. And in this case, ADI has confused the RDI subtraction a little bit and made things a little bit worse. Again, so here it spits out contrast curves. So here, these dotted lines here are just sort of the 5 sigma, normal contrast, and then these solid lines here are the ones that have been calibrated for the CLIP throughput and the coronagraphic mask throughput, and you can see kind of where HIP65426b lies on those images. So yeah, if you're interested in PanCAKE, that's where you can go to check it out. I think it's very simple to use, but if you're having any issues, please do reach out to me or make a GitHub issue.